we got this digital multimeter right here, and we got red cable and a black cable connected. We're gonna go ahead and plug the red into this side of the ohm thing.
Resistor.
This is a resistor, and then we're gonna put the black one in here, and apparently this is going to read it because it's marked on ohms here, by the way. So it's 98.9 ohms. The next resistor is going to be 300. Let's just see if that works. So 297.5. It's resistor 500 here. 496.2.
This is 999 ohms, so 0.999 kilo ohms. So, which is this resistor right here.
All right. So first, we got our power supply. We're going to take this plus. We're going to follow that. We're going to put the plus directly into the blue ammeter in MAs here. Then we take our comm from the MA thing and go over here and put that into a resistor. This is the 1000 volt resistor, the 1000 resistor. And then that'll connect back into the ground over here. So we complete our circuit. The reason we did this entire loop here is because we wanted to make sure that it was going through this thing before going into our resistor. But now what we're going to do is we're going to touch this yellow thing, and we're just going to connect it immediately into the resistor like this without having it go through the power supply.
Where the red one is says V.
So as usual, these things need to be turned the current all the way to the right and the voltage all the way to the left before we turn on anything. So we want to make sure that on this voltage meter it's set to V because it's reading voltage. On this one we've set this to it's amps over here.
400 microamps.
So we're reading amps. So the cool thing is that this is giving us very precise readings, as you can see, and they're going to be exactly the same. And over here we have more of a sort of a general reading. So even though we're kind of like turning this knob, we want to be reading this voltmeter to get us the correct settings. And we're just going to just very slightly twist this up until we get about 2. It should be okay. Now we're going to go up to 3 volts, again using this to sort of fine tune it. Bam, we got a nice little reading right there. Let's see what numbers we get. Let's see if we can increase that to about 4. So now we're getting too high of a number, which means we have to adjust this valve as well, even though that decreases the sensitivity. Just got a few more to do. Number 7. And our final value at 10. So we noticed that at each of the voltages, the current was the same for that resistor. And so when we calculated resistance equals volts over amps, we just found 1000 ohms, which makes sense for that resistor. So first, we're just going to set up our circuit. We've got the plus heading into the capacitor 1 right here, and then we're continuing that circuit into the next capacitor, which returns back into the ground. But then we're going to need to use our amp meter here to measure the amps on both of them, so we kind of have to insert this into our circuit somehow. We do just like we did before. We take our plus, put it into this, take that from the comm, and put it into the resistor. Now we're ready to read this. We are going to set the voltage to 5, and then we can start to read the current, that's going to be I, in the resistors. And the current's actually going to be the same through both of them, so we're getting a reading of 3.3. So when currents are in parallel, you're going to combine them, so you get these two to combine the current. But when the currents are in series, then the currents are actually the same. And so these things are in series, so their currents are the same. So the interesting thing about this voltmeter is that it's going to read voltage. So imagine this battery kind of like on our circuit board. We're going to attach one side of the voltmeter to the positive side of the battery and one side of the voltmeter to the negative side of the battery, or the ground rather. And we're going to see what's the difference of voltage between those two. and it turns out to be 5, just like it was marked right there.
Here,
Next, we're going to use the voltmeter to measure the voltage across this resistor right here, which turns out to be 3.3 or something. We're also going to measure the final one right here on the 500 by plugging it into there and seeing what happens over here. So first we measured our currents and we found that they were all the same. And then we measured the voltages and we discovered that these two are simply a combination of so V equals V1 plus V2. Notice how on our diagram, the resistor will split apart into 2, and those are parallel resistors. So these are connected in parallel because notice how from the power supply, it's connecting to essentially both of the resistors at the same time, just kind of like it was in the diagram. And then the charge will go through both resistors at the same time and come back in to the battery. That's in parallel. And that differs from being in series because remember in series how it went from one to the next, to the next, to the next, whereas in parallel it goes through both of them simultaneously. So apparently the voltage is going to be reading the same across every point, 5.016, no matter how we set this up. So in order to read the amps, it's a little bit more difficult. We have to take this apart and we plug the plus side directly into the amp reader over here. We make that mistake a few times before. And then we have the COM that's going to plug directly into the resistors over here. And then the circuit continues as it did before. So we're going to set the voltage to the power supply at 5. And we're getting a reading of 14.6 from the power supply only. So we're taking, in order to connect these in properly for the amp meter, we have to do this right. So we go from the plus, and then here, the charge is going to try to split up and go through that resistor, and it's going to try to go to the other resistor. But before it goes into the other resistor, we're going to take a detour through the amp meter, and then into and then into the resistor. Okay, so yeah, we're just taking a detour and then it's going through there. So we're just kind of bypassing that one. We're not reading that one, we're reading this one. It's complicated. So I guess we got a reading of 4.97 milliamps across this particular resistor. So the current's going to come out of this battery and it's going to want to go through both capacitors at the same time, but we're going to take a little detour before we hit that one. So when we turn this on, we get a reading of about 10 on that one. So because these capacitors were connected in parallel, notice how the voltage or the current at the beginning was just equal to these two currents. Now we're going to be setting up this particular diagram. Got our power, we're going to connect it to the blue ammeter like this, and then we go through the resistor 1 like this, and then we're going to head through both of the other 2 resistors over there, and then it's finally going to connect through the last resistor down over there, as you can see, and back into the power supply. So first we're going to measure the current in the circuit. That's what we connected this the amp meter here for. And then once we've got that, we're going to use the other reader here, the voltage meter, and measure the voltage in the power supply right there. Power, and then in resistance 1, resistor 2, 3, 4, and the A there. So the amps coming through the power supply is going to be 3.87. That's going to be for the current. Now we're just going to measure the voltage from the power supply. It's going to be about 5. Next, we measure the voltage on the amp meter, which is going to be about 0.04. Now we've got resistor 1 at 3.8 volts. For resistor 2, this is going to be 0.72. Since resistor 3 was the exact same as resistor 2, the final resistor is going to be about 0.38. So we were able to measure the current in the circuit and all the resistances for the resistors. So when we add them up to create an equivalent resistor, then we get basically 1294 ohms, and then we can sort of divide that by plug in the volts And finally, we can get the current in terms of the calculated current and the measured current. And as you can see, we had 0% error. It's pretty cool.